Hey guys, welcome back to the channel. Security is a very deep conversation. When we think about security, we have so many different meanings about that in life. A security system or a secure environment, secure data. It could even be, our houses are secure, right? So we look at security from different lenses. When we think of our finances, we think of financial security. So the word security is really, really deep and has far-fetched meaning and implications to, in general, our day-to-day lives. What I want to talk about is the most important aspect of security from a software perspective. Security in computing, and that's what this video is all about. I'm going to touch on two key topics and introduce you to a concept of CIA, which is a very well defined industry model fundamentally used to talk about security. And then we'll also talk about how different forms of vulnerabilities could kick in. This is not a very deep dive session, but this introduces the idea and gives a little meaning to security in computing. All right. So on the screen, we are seeing two images. Let's talk about this, the left hand side first. So essentially, if we talk about confidentiality, confidentiality ensures that the computer related assets are accessed only by authorized parties. And this really means is essentially only those who have access to something will actually get access. And access here doesn't imply really, reading or editing. Access could be defined by a multitude of different roles. It could be, it could be about the ability to print or something. It could be the ability to share something. All right. So coming back to it, security is really written and thought from the perspective of why am I not secrecy or even privacy for that matter. So when we talk about confidentiality, we are really thinking of the secrecy and privacy and access related controls, whether the person, the right person who is supposed to have access to perform a certain operation really has the access. This is usually defined across levels 0, 1, 2, and 3. 0 meaning most open or public for most enterprise use cases, 3 meaning most confidential, and then the intermediate stages could be private, proprietary, confidential, and secret, and so on. Different organizations will want to tag different associations, but usually this is a very well defined and understood structure. It's important to note that confidentiality even goes to the level of the access, talks about whether even you are aware of the existence of the data. So that's also covered under access. Now, moving further into integrity, integrity really means that the asset can be modified by authorized parties and in authorized ways. And here in this conversation, authorization could refer to changing, deleting, modifying, and even creating an asset. An asset could be anything in this in a system context. Could be largely data, that's what we usually talk about, but asset could be the complete software system itself or an hardware element. These definitions are inclusive of the idea of hardware, software, and data. So when you have an integrated system, when you have high integrity in the system, you have a good degree of control and change management. And then finally, availability means that the data is available during whenever it is needed to the people who are supposed to have access. So whenever you achieve this, you essentially have a secure environment. Let me just hop on to Google and share some of different images in here. This is what I was talking about. So confidentiality again prevents unauthorized disclosure of information. Integrity would prevent unauthorized modification, and availability is more from a disruption of service or rather availability of data. And that's the CIA triad, which is really, really important from an industry perspective. The second topic to understand and think about is vulnerabilities. When you think of a system, you have a normal flow, which is something of this kind. So what can happen in this, and this, the assumption here is this is a secure system. However, when you think of vulnerabilities, what would we want to imagine? We could imagine an interruption of service. We could imagine an interception of the service. So essentially a bifurcation. Could imagine a modification, and a very good example of this, which is popular, is man in the middle attack, or fabrication, which is phishing attacks. So I'm not getting into the specifics of the examples of this, but when we look of vulnerabilities for each of different kinds, you could have different meanings. For example, in the context of hardware, we have learned about denial of service attacks, which is a type of interruption behavior. When we talk of interruption of softwares, it could be modification or deletion, for that matter. For data, it could be loss. So all of these can be fundamentally defined over for hardware, software, and data, which is essentially, that's the whole set of IT systems are a combination of this, right? So in a nutshell, what we have talked about is CIA model, the triad. And when you think of security, or when you want to understand security, this is the first thing you start with. So think of it as the giving meaning to computer security. And the second aspect is, how do you measure vulnerabilities? You can obviously go much more deeper. You can understand the methods of defense. You can get into the data encryption standards. We could talk about cryptography. You could get into, how do you define controls against threats, authorization, authentication management. You get into the system design aspects of how do you design a software system which are inherently secure and support all of these systems. And then there's different proposals and multi-level security, network security, all of that coming into picture. But when we start to think about security, this is a very good starting point to do. All right, that's what I wanted to share in this video, the CIA triad and the ways of measuring vulnerabilities. Give thumbs up if you liked something, comment if you want more videos around security. Thank you, till next time, bye bye.